thank you for joining me today as we're going to talk about something that gets referenced from time to time around here, but which we may not know everything about that we really need to know, and that is the ASTM D975 diesel fuel specification. So what we want to do today in order to better understand this issue is we want to try and cover, first of all, the purpose of D975. Who decides to put it together? Who decides what goes into it and why? And speaking of who decides, how did ASTM put D975 itself together? Was it decided by some kind of dictatorship? Did Kevin and Stewart or some other minions come up with the idea? I mean, what's the deal? We want to understand how ASTM goes about putting together these standards. And then, of course, once we cover the why and the how, we do need to cover the what. What are the requirements going into D975, and what do they mean from a practical standpoint? So the best place to start is talk about the ASTM organization itself. In a nutshell, ASTM's purpose is to create standards for many of the things that we use in everyday life and in business. ASTM itself, of course, is an acronym, stands for the American Section of the International Association for Testing Materials. It used to be called, more simply, the American Society for Testing Materials, but added that international designation in 2001 to better reflect its global influence. Now, it was originally started way back in 1898 by a group of scientists and engineers who were working in the railroad industry, specifically for Pennsylvania Railroad. And at the time, there were tremendous problems with rail brakes. So their first job was to develop a standard for the steel that was used to fabricate the rails. And it's interesting to look back and see that at first, at the time, industry was very resistant to the idea of defining standards for things like steel and railroad ties. They were afraid that doing this would just cause mass business anarchy or hysteria. Everyone would just find ways to default on contracts. But over the years, business and industry really began to see the value in doing this kind of thing. So they came around in a pretty big way, and so here we are today, where we have ASTM being made up of committees that span across all kinds of industries and areas. And these committees are the ones that decide what the standards should be. They're typically composed of people who have some kind of interest in whatever thing it is that they're looking at. And that means that on an ASTM committee, you can have users of products, you can have producers of products, you can have just general consumers, or just people out in the public who are interested in that particular thing. Some examples of committees. You could have Committee B01, which is the Electric Conductors Committee. You could have Committee D10, the Packaging Committee, and D13, the Textiles Committee, and F26, the Food Service Equipment Committee. Currently, ASTM has over 30,000 members from over 140 countries, and there are more than 140 technical committees. Now, ASTM's job is to formulate standards for many of the things we use. We said that there were more than 140 technical committees, but when you look at the standards, there are more than 12,000 ASTM standards that have been created and are adhered to by some significant party. Now, why are there so many standards? Well, think about all the things we use, and think about the assumptions that you have as a user when you go to use them. Now, you proceed under the assumption that that particular thing is what you think it is in terms of its properties. So you buy a cardboard box because you're moving. So you buy a cardboard box, you assume that the walls of that box are going to be a certain thickness and that the box is going to have certain abilities that will help you do what you bought it to do in the first place. Now, all those things have to be defined. or else anyone could just decide whatever they wanted those things to mean, and you could end up with a cardboard box that has sides that are, a sheet of paper or something. And we're not just talking about weird stuff that no average person cares about, like defining the distillation range of some chemical nobody's heard about. There are ASTM standards that define all sorts of useful things, like A492, the standard specification for stainless steel rope wire. I guarantee if you're going across a bridge, you want that stainless steel rope wire to be, what people expect it to be. There's E112, the test standard for determining average grain size in farming. You bet farmers care about that. And C91, the cement and concrete standards. I bet every driver that's going down the road or uses the sidewalk, I bet they care about that. So almost anything you can think of, there is at least one ASTM standard that played a key role in ensuring that that thing is or was what you thought it was. And so how does ASTM come up with a given standard? Now, without spending too much time in the weeds on this particular issue, the basic process might go something like this. Once someone decides on a topic that needs to have a standard developed, they form a task group, and that task group does the legwork and the research that forms the basis of a draft standard. And they submit their findings in that draft standard for review and voting, where it is reviewed, discussed, and voted on by a series of subcommittees, and then the main committee within the ASTM. And if all those committees look it over and agree that it is worthwhile, then it's put up for vote by the entire society itself, which has to approve it before it can become an official ASTM international standard. So, as you may be able to tell, this process ensures that only fully vetted and agreed upon standards actually become written into law, so to speak. So, a couple other things to remember before we proceed. First, in the course of producing the information that they think people need, ASTM will produce a couple of different kinds of documents. They will produce standards and they will produce test methods. Now, they're both important, and they're both related to each other, but they are different and distinct from each other. So, the thing we referenced at the beginning, D975, the base thing that we're talking about, that is what is known as an ASTM standard. And so it is a broad set of guidelines and requirements that define the quote-unquote standard specification for something, in this case diesel fuel. So D975 is a standard that defines what diesel fuel is supposed to be. But in order to have this kind of standard, it has to be made up of components, things that go into composing the standard. Just like you don't have an engine, you have a bunch of components and parts that when you put them together, you make an engine, right? So in the case of diesel fuel, what ASTM has done is basically this. They figured out that, and by they we mean the people making up the pertinent committees. Those people figured out that there are certain properties and certain characteristics that should define diesel fuel. And so they then, once they had those, they determined the test methods that measure or prove or show whether diesel fuel has those properties. And if it does, then together those things define what diesel fuel is. So for ASTM D975, it is a standard that's made up of test methods. In order for diesel fuel to meet the D975 standard, it has to meet the defined results for all the tests that ASTM has determined it needs to meet. Okay? And one other thing to remember is that even though we're mentioning testing, ASTM itself doesn't do any actual testing. What they will do is determine what group of tests should comprise a given standard and what kinds of test results should be the standard for whatever they're talking about. But ASTM itself is not in the testing business. Now, with respect to ASTM's influence, you have to understand that ASTM itself has no clout and no role in forcing anyone to adhere to whatever standards it comes up with. That clout actually comes from when someone else, like, for example, the United States government, when someone else important decides as an ASTM standard for, whatever the definition for a given thing, they, basically it comes from when they decide that, hey, the ASTM standard should define whatever it is we're talking about. Now, this idea that the United States government could tell everyone that they need to adopt the ASTM standard, that actually is not just something that the federal government just made up on a whim. It actually comes from a piece of legislation, specifically the 1995 National Technology Transfer and Advancement Act. And that act requires the federal government to use privately developed consensus standards whenever possible. Of course, the government had been doing that, long before 1995, but the 1995 Technology Transfer Act codified what was already a best practice. And so this is what happens in reality across lots of different areas. You'll have local and international governments that reference ASTM standards. You'll have corporations that do business internationally. They will reference ASTM standards to provide a generally accepted and robust reference point for the things they're buying and selling. Another example, take ASTM F963. This relates to toys, and the federal government has dictated that all toys sold in the United States have to meet safety requirements that are found in F963. It's kind of important for kids to play with, safe toys, right? Well, that's an example of the federal government saying you guys need to pay attention to the ASTM standard for that thing. So that's the kind of situation we have with a similar requirement for D975, the diesel fuel standard. The federal government decided that the D975 set of rules were what best defined the thing called diesel fuel. And so they basically made it known, if you want to call something diesel fuel, it has to meet the definitions listed in D975. And that means that whatever particular thing that you're trying to call diesel fuel, it means that has to meet all the particular stipulations contained in D975. And just to be clear, it also implies that if a particular thing is not contained in D975, then your fuel doesn't have to meet that in order to legally be diesel fuel. And one example of this, if you think about it, let's say someone's got some diesel fuel, and they want to add blue dye to the diesel fuel. Now, D975 doesn't say anything specifically about color itself. It says that the fuel has to be, quote-unquote, it has to be clear and bright and free of visible particulate contamination. But it doesn't say anything about color. So someone can add blue dye and legally call it diesel fuel. Now, that's not to say that there might be some other regulation, somewhere else that says we don't want you coloring your diesel fuel blue. But as far as the federal government's concerned, you can add blue dyed diesel fuel, and it's still diesel fuel because D975 does not address color. So now that we have all of this background, all the background information we need, let's dive into the D975 standard. Now, its official title is the Standard Specification for Diesel Fuel Oils. Typically, all ASTM standards will have written paper copies. And if you had one of those and you started leafing through it, you would find that it is divided into about 10 sections, 7 of which are the ones that make up typically the actual standard itself, and then section 8, 9, and 10 actually correspond more to like appendices. So section 1 of the written standard is scope, and it's a short one, it tells you what D975 actually applies to. And if you read through it, it starts by saying this specification covers the 7 grades of diesel fuel oils suitable for various types of diesel engines. That means what that's telling you is that this D975 standard has information in it that's intended to apply to number 1 diesel fuel oil, that is what they call S15, S500, and S5000. It applies to number 2 diesel fuel oil, that is also S15, S500, and S5000. And it applies to number 4 fuel oil. Those things. Notice that it does not specifically cover number 6 heavy fuel oil, or HFO. That's probably because first of all, number 6 isn't commonly used in diesel engines. Remember that last part of the scope, fuel oils that are commonly used in diesel engines. So HFO is not commonly used in that. Even though there are some kinds of stationary internal combustion engines used in power generation, it's not considered a common usage. And I think the second possible reason is because the number 6 HFO is the residual. It tends to be the residual fuel oil that's left over after the lighter distillate fuel oils have been taken off. And that means that you're basically number 6 is everything that's left, and it's much harder to control the properties of that in terms of its composition, and therefore, it's much harder to have a standard that says, it has to have this composition because of the nature of what it is. Okay, so that's Section 1, the scope. Section 2 is reference documents. This is where they lay out all the other ASTM test methods and other ASTM standards or related documents that apply to the things that they're talking about in the standard. And we'll see some of these as we look a little bit more closely at it. Now, in the digital copies of D975, they will typically have those helpfully linked so that someone can dig into that PDF or that digital copy, and they can click and they can go straight into whatever the test method was linked, and they can find out all the information they need to know about what that is and how to run it, et cetera, et cetera, et cetera. So that's reference documents, Section 2. Section 3 is terminology. What do different terms mean? Now, this is a relatively short section. And the biggest thing that they want to communicate in D975 with respect to terminology is what do these S figures mean? When they say in the scope, this applies to number 2 diesel, that is S15. Well, what does S mean? Now, if you're familiar with fuel, as all of us here are, it probably won't take you very long to figure out that S corresponds to sulfur content. So what they're talking about is, S15 is ultra-low sulfur diesel. S500 is low sulfur diesel. And then S5000 is the old high sulfur diesel. Section 4 is test methods. This is where they lay out in a little bit more detail the names and identities of the tests that should be used to determine whether a diesel fuel meets the various parts of the standards. Now, if that sounds complicated, we'll explain it. We'll explain it a little bit more here in a minute. Hopefully, we'll be able to clarify some of that confusion. Section 5 is titled Workmanship. It's also a relatively short section, and in this case, they are referring to workmanship requirements of the diesel fuel. Now, you might say, well, that still doesn't tell me exactly what they're talking about. Basically, it's saying what it should look like. When they finished producing this, what should it look like? And all the Section 5 says is the diesel fuel shall be visually free of undissolved water, sediment, and suspended matter. So they've spelled out that requirement, and that's important now because those aspects of the diesel fuel's appearance are now part of the legal definition. Also, note that just a minute ago we were wondering why number 6 was not considered part of what D975 applied to. Well, it's because number 6 is impossible to meet this workmanship requirement. Number 6 is never visually free of undissolved water, sediment, and suspended matter because it's the residual stuff. So that's probably a third answer as to why D975 doesn't cover HFO. Section 6 is requirements, and it tells you that the grades of diesel fuel oil herein specified shall be hydrocarbon oils conforming to the detailed requirements shown in Table 1. Basically, that's the section that's explicitly telling you it has to conform to all those test methods found in Table 1. And then Section 7 is keywords. That's just a cataloging function for it. Now, remember we said that it actually contains 10 sections. Sections 8, 9, and 10 are the last parts of the document, and they're the ones that actually take up the most space. They are the appendices and the reference materials. See, ASTM, the helpful people that they are, they put a bunch of information in there that's intended to augment and support the actual requirements. So they'll put things in those appendices like what are the ideal storage conditions for fuel, or reference information on things like what's the typical ambient air temperature for given parts of the country. So that's sections 8, 9, and 10. And so those 10 sections together form D975. So the detailed requirements for diesel fuel oils. Let's get down to the nitty-gritty of what defines diesel fuel. Now, for our purposes, we're going to be looking most closely at number 2, especially ULSD. So what you see on your screen, that is the aforementioned Table 1, or rather, it's a depiction of it. Table 1, detailed requirements list. Now, up top, we have the different grades of diesel fuel, and then if I can get my pointer here. Yeah, here we go. See. Okay, so up top, you have the different grades of diesel fuel. And then along the side, the y-axis, you have the different tests. And then the required values are listed out in the tables here. Now, the bottom line here is that in order for a given fuel or a given liquid to be legally defined as, say, low sulfur number 2, then it has to meet all of these requirements down here. And since these properties, since all of these things here actually correspond to different ASTM tests, and it's really saying it just has to meet all those test results. Now, defining these properties as tests, or rather defining the tests that can measure these properties, that's important because if the tests have corresponding ASTM numbers, then that means anyone can take a fuel sample and they can run a specific test protocol, and they can determine for themselves if that sample meets the criteria, provided that they have the required equipment and that they're able to execute the given test in the manner prescribed. So let's go through what these properties are that diesel fuel has to meet the minimum standards on. Many of these are specifications that you have heard at times in other areas. Now let's go through these individually, and as we do that, we should start to see how these properties really are important for making sure that diesel fuel does what we need it to do when we go to use it. So going from top to bottom, we start at flash point. Remember, top to bottom. So we start here, and we're going to work our way down. So the first one here is flash point. Now, this one is fairly simple. Flash point is defined as the minimum temperature at which something will ignite in the presence of a flame or an ignition source. Now, this is different from another temperature you might have heard, auto-ignition temperature. Auto-ignition temperature is significantly higher than flash point because it's the temperature that speaks to how hot something has to be before it will self-ignite without any ignition source. So, what are the requirements? Number 2, diesel is supposed to have a minimum flash point of, here, 52 degrees centigrade, which is about 125 degrees Fahrenheit. Kerosene itself, which is number 1, diesel fuel, is allowed to have a lower flash point, around 100 degrees Fahrenheit, 38 degrees centigrade. Now, why does flash point matter? Why did they include it? Well, flash point matters because of how diesel fuel works in a compression ignition engine, which is what a diesel engine is. If the flash point of the diesel fuel is too low, like, for example, if you try to put gasoline in a diesel engine, well, gasoline has a flash point of minus 45 instead of 125. If the flash point's too low, it will ignite too quickly in the diesel engine, and it will damage the engine. The engine's not going to work right. So flash point is important to have, or I should say it's important. I said important to have. Everything that burns has a flash point. What I mean is it's important to have the right flash point. Second is distillation. This is referred to in the specification as either physical distillation or simulated distillation, and it is it right here. In order to run this kind of test, they heat the liquid up until it turns into a vapor, typically using this kind of apparatus. So they heat it up here. They'll have a Bunsen burner or heating apparatus, and it will turn into vapor, and it will go up into a distillation column, and then it will start, and of course, as it moves away from the heat source, it starts to cool down, and as it cools, it will reach a point at a certain temperature where it will condense back into a liquid, and the apparatus is set up so that they can collect that liquid. And what they're looking for when they're running this test is they're looking for the temperature at which they can collect 90% of the original liquid's volume. 90% of it has condensed back and been collected back as liquid. In order to meet the standard, number 2 diesel distillation temperatures for 90% recovered has to be, well, this, between 282 and 338. 282 minimum, 338 maximum. If something's distillation temperature is off, then it's not going to burn properly in the engine, and it also is a hint that it might contain some things that it's not really supposed to contain, or it might have, shall we say, excessive amounts of some things like, let's say, aromatics that you may not want it to have. Right, so that's distillation temperature. Now, next one is the one below it, kinematic viscosity. Now, kinematic viscosity, we're all at least familiar with the concept or the observation of something that has a high viscosity. Viscosity itself is an expression of internal friction in a liquid. And we all know some liquids that have high internal viscosity because they're thick and they don't flow well, like molasses or honey. And then we all know that there are thin liquids that have low internal friction, like water or mineral spirits. The requirement is for number 2 diesel to have an internal kinematic viscosity between 1.9 and 4.1. Now, question for us is, why does viscosity matter? Who cares if it's between that? Well, viscosity affects how the fuel is injected by the injectors, and you definitely want those injectors to function correctly. And if something is too viscous, then it's the injectors, first of all, they're going to work harder to inject it, and it's not going to, since the system is calibrated to work properly, it's not going to inject the right amount of fuel at the right time. It's not going to work properly. So kinematic viscosity for diesel fuel oils is defined in D975. Next one's ash percentage. Ash content, on the face of it, seems pretty important. You want the fuel to burn cleanly and completely, and not produce a bunch of leftover ash that could damage areas of the engine. Ash itself, whenever you see ash, what you're seeing is a combination of partially burned carbon components and leftover inorganics like metals. So when you burn charcoal, for example, and you get ash in the bottom of your grill, well, some of that's partially burned wood components because charcoal is made from wood, and then there's also metals that existed naturally in the wood tissues, and so those are not going to burn because the only thing that really burns is carbon, and so those are left over in the ash. And so diesel fuel, fuel that's going to be burned in an internal combustion engine, that has a maximum ash content of, if we look at the thing, it is 0.01% by mass, because they don't want fuel making a lot of ash in the engine because that can damage the engine. Next one, sulfur content. We are all, or should be, well familiar with the sulfur issue and all the reasons why things are the way they are. So D975 is one of the places that spells out the requirements. 15 parts per million for maximum for S15, 0.05%, which is 500 parts per million, and 0.5 or half of a percent for the S5000 diesel fuel oils. Number 6, copper strip corrosion. You can see here, you see this copper strip corrosion, number 3. Copper strip corrosion is a test that tries to verify that a diesel fuel is not going to cause corrosion damage when it has long-term contact with metal parts. I mean, you don't want your fuel or your oil or something to corrode what you put it in, right? Well, copper strip corrosion aims to make sure that this is the case. And the copper strip corrosion test itself is run by taking a strip of copper metal, immersing it in the test liquid for a defined period of time at a defined temperature, and then they take it out and they compare it to a visual chart, which is what this is. And it gets, based on what it looks like, it gets one of these grades. Number 2 diesel has to be a grade 3 or better. And by better, we're talking about this way, not this way. Cetane number. Cetane number, we are, or should be familiar with the importance of cetane in diesel fuel. Diesel fuel has to have minimum value of 40. That's defined by the regulation. Now, what we can also see is that there's actually, if we go back to the chart, assuming that we have the correct table up here, what you see here, you see cetane number minimum 40. That's good. But then you've got this thing here, one of the following, cetane index or aromaticity. And this is interesting because what it's saying is no matter what, the diesel fuel has to have minimum 40 cetane. But then it says, in addition, if it's low sulfur, and then you don't see it on this table, but it has the same requirements for ultra low sulfur. If it's low sulfur or ultra low sulfur, not only does it have to have a minimum cetane number, but it also has to have at least one of the following also be true. It has to have a cetane index minimum of 40, or it has to have a maximum aromaticity of 35%. Now, what's the point here? It looks like, or it seems like, that they're just duplicating things. Well, what they're trying to do there, of course, they're trying to make sure it has adequate cetane, but what they're also trying to do is make sure that its composition is right. If you've ever been trained on cetane number, if you've ever heard a technical discussion, you know that cetane value of a diesel fuel is actually the average of all of the cetane values of all the 100 or so different components of diesel fuel. What that tells us is that refineries can vary the composition of, say, a number 2 ultra low sulfur diesel. They can add and subtract things in order to get that fuel to have the properties they want it to have. One of the things that they can add or subtract are these what they call aromatic compounds. Corresponds to this thing, aromaticity. And what the D975 standard is trying to do is actually put a cap, a maximum, on the amount of aromatics that can be in diesel fuel oil. Aromatics can affect cetane number. They also affect air quality. They affect emissions. In fact, they dramatically affect emissions, and that's why they cap the aromatics. So, has to have a minimum cetane number, and it has to be able to achieve that by not having too high a content of aromatic molecules in it. The one below it, Ram's bottom carbon residue. If you've got kids or if you've ever seen Despicable Me 2, I think, as soon as we say that, when we say Ram's bottom, well, we think of, I'll just, leave it to your imagination, or go on YouTube and look it up. But Ram's bottom carbon residue, that is basically the residue that's left over after it's burned. It's carbon residue. It's different from ash. And number one and number two diesel are capped at 0.15% and 0.35% respectively. And to be specific, the Ram's bottom carbon residue is the measurement of the residue that the fuel is going to produce at high temperatures, such as those you might find in a diesel engine. Now, obviously, you don't want the fuel to make a lot of residues. So a high score on this carbon residue test probably means you're going to have high amount of combustion chamber deposits formed, and you don't want that. And then the last one here is lubricity. Again, we know that lubricity refers to the lubricating abilities of the diesel fuel. And they measure it using an HFRR test, a high-frequency reciprocating rig apparatus. All diesel fuels have a maximum score of 520 because on that kind of test, lower is better. So that is the D975 standard specification for diesel fuel oils. Diesel fuel has to meet all of those requirements in order to be legally identified and labeled as diesel fuel. Of course, we know that over time and given certain conditions, some of these properties can degrade and they can fall below specification. And this is one of the value points of what we do and what we offer with Bell Fuel and Tank Services, Bell FTS program. We can provide testing to assist our customers in making sure that the fuel's still in spec. And then we can make the right recommendations for the solutions to fix whatever those issues are out of line. So that should give you most of what you need to know about the ASTM D975 standard. If you have any questions, then you know where to find me. And this concludes our time together today. Thank you very much for joining me for this training on ASTM D975, and we'll see you next time.